In this demo, we will show how to connect a PROFIBUS Master to an Ethernet IP adapter or slave. To do this, we will use an Anybus X-gateway, which acts as a translator between the two networks, allowing them to communicate. In this setup, I'm using the Anybus PROFIBUS Master simulator software as PROFIBUS Master. This could also be, for example, a Siemens PLC. The PROFIBUS Master simulator is connected to the bottom interface of the Anybus X-gateway. On the top interface, which is the Ethernet IP scanner, I have connected two I/O blocks from WAGO. I want these to exchange data with the Profibus side. I have also connected my computer to the X-gateway via the USB port, so I can access it for configuration. To configure my X-gateway on the Ethernet IP scanner side, we need to create a scan list. To do this, we first need to determine the assembly instances and I/O sizes of the WAGO modules. Usually, this can be found in the documentation or the EDS file of the Ethernet IP adapter. In this case, we can find it on the internal web pages of the WAGO I/O blocks. I log on to my WAGO I/O block by typing in one of their IP addresses, 192.168.1.2. I go to the Ethernet IP page. Here I find information about the assembly instances available for this device. We want to make a connection using both input and output data, so this gives us an input assembly of 108 and an output assembly of 102. These are also referred to as connection points. In our setup, they are both 1 byte. Okay, so I now have the information I need to set up an I/O connection, also known as a scan list. I now open the web page of the Anybus X-gateway, which I can find on the IP address 192.168.1.1. It is also possible to use Rockwell Automation's RS networks for Ethernet IP, if I'm more familiar with that. I open the scan list page, which is currently empty. In order to be able to edit the scan list, I must change the gateway operation mode from Run to Idle. To do that, I need to start my X-gateway configuration manager. Here I select Online and select Connection. I click Config and then select the Anybus X-gateway, which is connected to my computer via the USB port. I click OK and then the Connect button, and can then go to the Tools menu and select Set Operation Mode. I set this to Idle. OK, I now go back to the Anybus X-gateway and refresh the web page. I now have an option to add devices to the gateway, so I click Add and enter the IP address of the first WAGO unit, 192.168.1.2. As you recall, I want to send 1 byte from the master to the slave, so I enter that I want to send 1 from originator to target. I also want to receive 1 byte from the slave. I enter this in target to originator. Under connection points, I enter the 2 connection points I got from the WAGO unit webpage. This was 102 for the digital output and 108 for the digital input. I now do the same for the other WAGO I/O block that is located on 192.168.1.3. The data size is still 1, both for the data from the originator to target and from target to originator. And the connection points were 102 for the digital output and 108 for the digital input. Okay, so I now have my scan list here, where I can see my 2 I/O block adapters. They both have 1 byte of input and output data. On the second I/O block, I have an offset of 1 word. This means that we will have 3 bytes in total. This requires some explanation. If we look at the input data, we have the data from slave 1 in the first byte of the first word. The second slave needs to start writing on the next word, so we will have an offset of 1, meaning that the second byte of the first word will be unused. The data from I/O block 2 starts on the first byte of the second word, and consequently the input size is 3 bytes. It's the same thing with the output data. 2 bytes of data and 1 offset, meaning 3 bytes. To enter this data size, I go back to the Anybus Configuration Manager and click the Upload button to upload the current configuration to the Anybus X-gateway. I go to the Ethernet IP scanner, and I can see that the default is 20 bytes in and out. This would be fine for this configuration, as it's bigger than the 3 bytes for my I/O blocks. But just to show you my superhuman powers, I will change this to 3 bytes on the input and output side. I also do the same thing on the Profibus side, 3 bytes in and out. And then click Download. When I download this to the gateway will be automatically set to Run mode. On my I/O blocks, I can see that all LEDs turn green, which means that we're communicating between Profibus and Ethernet IP. In my Monitor tab, I can see that I receive data from both Ethernet IP slaves. To show the Profibus side, we have the Anybus PROFIBUS Master simulator, which acts as the master in my scenario. So if I click the Connect button, I can see the configured data from the Ethernet IP slaves showing up here as well. I set the lowest bit in my Profibus Master simulator. This turns on the first LED connected to the first I/O block. If I set the next bit in my first byte, this turns on the next LED connected to the same I/O block. And if I switch on a button on the I/O block side, I can see the data change here on the Profibus side as well. So now I have a working connection between a Profibus Master and 2 Ethernet IP slaves.